Now that we know what are the categorical variables in our dataset, we can start transforming them into numerical. To transform a categorical variable into numeric, we have to understand its type first. There are two types of categorical variables, ordinal and nominal. Ordinal variables have two or more categories that can be ranked or ordered. In our case, there's the salary column where the values clearly have a logical order. The second type is nominal, where categories do not have any intrinsic or logical order. An example of this kind of variable in our dataset is the column department, as its values clearly do not have any order or rank. Sales department is not higher than HR or vice versa, and so on. Based on what type of categorical variable you have, there are different methods for transforming them. For the case of ordinal variables, we can encode categories by converting each of them into respective numeric value. There are 3 steps to accomplish this task in Python. First, we have to tell Python that the column salary is actually categorical. This is done by using a method called asType, which is providing the type of the variable. Then, once Python knows that it's a categorical variable, we have to tell the correct order of categories using catReorderCategories method. As you can see in the code, this method takes the list as an input where the correct order of categories is provided. Last but not least, we have to use catCodes attribute to encode each category with the numeric value given our order. The result will override the old values of salary column with new numeric values as presented in the table. The next categorical variable is nominal, and there is no order or rank between departments. This means that the encoding approach is not useful anymore. In this case, transformation should be accomplished through so-called dummy variables. Dummy variables are the variables that can only get 2 values, 0 or 1. Let's say an employee is from the technical department. This means if we have a separate column for each department, then the mentioned employee will have value of 1 in that column for technical and 0 in all other columns of departments. This means we will have to create a new data frame where each department is a separate column and each row is a separate employee with 1s in front of his/her department and 0 in all other places. While the task seems to be confusing, it's very easy from technical perspective due to a very nice function from pandas called getDummies. While dealing with dummy variables, one should be cautious of a phenomenon known as dummy trap. The latter is the situation when different dummy variables convey the same information. In this example, the sample employee is from the technical department, so it's the only column with a value of 1 in the first table. In the second table, the last column is dropped, but we can still understand that the employee is from technical department by looking at all the other departments that have value of 0. For that reason, whenever in similar situations dummies are created, one of them can be dropped as its information is already included in others. Okay, time to put this